So here's a little comparison of how permutations where the order matters is different from a combination where the order doesn't matter. So a reader wants to choose 3 books from 4 books. It doesn't matter the order that you choose those books. You're going to have read them all in the end. You're not arranging them on a shelf. Or it's like you win a prize. You have 4 books to choose from. You get your prizes. You get to take 3 of them home. Right? And so it doesn't matter the order that you choose them. You still get those 3 books to take home. So if you're looking at different combinations, well, you could choose book 1, 2, and 3. That would be considered one combination. In permutations, there would be 6 of them that are all the same. In permutations, 1, 2, 3 is different than 1, 3, 2, which is different than 2, 1, 3, and so on. So all 6 of those would be different in a permutation, but in a combination, you know, if you return book 1, 2, and 3, and you say, I don't like these, and they say, well, how about you take book 1, book 3, and book 2 then? And you'd be like, those are the same ones. I just told you I didn't like those 3.
Other than 2, 1, and 3.
So if you chose books 1, 2, and 4, that would be like all of those permutations. And so combinations are a bit like identical objects questions. In identical objects questions, we had to divide because we had some repetition. In combinations, we also have to divide because all of these permutations are considered repetitions of just 1, 2, 3. So we could take the number of permutations in this case, which is 24, and divide it by 6 because there are 3 factorial ways of arranging each of them to find out that when there's only 4 items and you want to choose 3 of them, there's only 4 combinations, even though there would be 24 permutations. So you could take the number of permutations and divide out the order, sort of like in identical objects, except the objects aren't identical, just the arrangements are considered identical when you look at them. So we have a formula for this if we take our permutations formula. Remember, our permutations formula is n factorial over n minus r factorial. And the combinations formula is just your number of permutations, and then depending on how big of a group that you have, you would need to divide by that factorial. So in our book example here, can you see that you're picking things of size 3, and 3 factorial is equal to 6, and that's how many repetitions of identical groupings there are. Unlike the permutations formula, which we hardly use, the combinations formula we will use a lot. And the combinations formula is really, as far as remembering it, I think it's even easier to remember than the permutations formula. So if you had something like 10C6, the formula would say you'll have 10 factorial on the top, and then you will divide by, and the bottom 2 numbers, one of them will be 6 factorial, and the other number will be whatever adds up to make 10. So if I had 7 choose 3, that would be 7 factorial over 3 factorial, and then the other numbers, what would add up to 7. So I actually find the combinations formula easier to memorize than the permutations formula. Later on, if you go to university, you might see this notation for combinations. We, in grade 12, we're going to be using the NCR. And you'll often, with the NPR, sometimes I use the English word pick. You have n things, you need to pick 3 of them in order. And I often use the word choose for C. you have n things, you need to choose 3 of them or r of them, and the order doesn't matter. But the big difference between a combination and a permutation is that the order doesn't matter. And the way that that shows up is you consider the order like an identical object, however big the grouping is, and you divide by that to make it work. So what are some examples of places where the order doesn't matter? Well, in a lot of lottery games, you choose numbers, and if you choose the same numbers that get appear, then you win. But it doesn't matter if the order is different. If they chose 20 first and you had chose 25th, it still counts that you have 20 and they have 20. So for Keno, there's 80 numbers to pick from, and you have to choose 20 of them. And I guess if you choose all 20, I've never played Keno, I guess you probably win a lot of money. Now to count how many combinations are possible, again, all combination questions, you're really going to use the formula a lot. You're going to say, I have 80 numbers and I need to choose 20 of them, and the order doesn't matter. Now we just need to go to our calculator and figure this out. So 2 ways you could do this. You could plug this into the formula. This is going to be 80 factorial over 20 factorial, 60 factorial. Those are going to be really, really large numbers. Not mental math. If we open up our calculator, there's also a choose button on our calculator. So I can go 80, hit the math button, over to probability, and the third one is choose. If I do 80, choose 20, I get a really, really big number. See that e to the 18? That means that it's in scientific notation. That's 3.535 times 10 to the 18. Now, the Keno lottery isn't something that I see advertisements for. Probably a more common lottery that we see here in Canada. Have you heard of Lotto 649? Is the 6 big and the 49 smaller? I don't know. There's not a dot in it either. Oh, well. Lotto 649 has been a lottery that's been around in Canada for a long time. There are 49 numbers, and you choose 6. If you get all 6 of those right, you win the jackpot. So how many possibilities are there? Did you know that you can guarantee yourself to win? You could just go out and buy every single ticket, right? For the Keno one, that's times 10 to the 18. That's a really, really huge number. The Lotto 649 isn't so crazy. If you did 49 numbers and you chose 6 of them, you could find out how many possibilities there are in total. So we go to our calculator, 49, math, over to probability, choose 6 of them, 13983,816. So just about 14 million possibilities. So if you wanted to, you could take that list of all 14 million, go to your local corner grocery store, and say, I'd like to buy some lottery tickets. Here's my list of numbers that I would like. Okay?
Just have them type it in.
I think, are they $2 a ticket now? Are they more? They're $5 now? They used to be like $1. Okay?
You're spending 16
But
million, almost 70 million.
if they were $5 a ticket times 14, you know, for a measly $70 million, you could win the lottery.
What's the lottery even? Which is it? Yeah, so it means you can make 30 million.
Yeah, if the lottery ever gets up to 100 million, then you just go to your bank and say, you know what, I've got a really good idea. you're going to give me $70 million and I am going to win the lottery.
And I'll give you 30 million back.
Now, there is only a little problem could be if someone else wins, right? So if it gets up to 100 million, right? If it gets up to a $100 million prize, I don't think I've ever seen it that big. Usually it's around, when it gets big, it's around 30 or 40 or 50 million. That's when it's really, really big. But if it did get up to 100 million, you could spend $70 million and guarantee that you'd win it, right? But the problem is, you go to your bank, they say, yeah, this is a good idea. They won't say that, but let's pretend they did. And they give you $70 million because they feel really good about this. And you win, but somebody else wins, you split it. And then you're only, what, down 20 million? That's
Not bad. You just try again.
You just have to work a few extra weekend shifts, right?
Yeah. Make it up in no time.
No problem.
Well, that's how they deal with duplicate numbers. Two people have the same number.
Yeah, you just split the pot.
Well, that's not fair at all.
So why I don't play the lottery is because this chance of me winning when I buy one ticket, 1 out of 14 million, is really, really bad. There, okay? You want to do something that's similar to this? Okay, let's.
Oh, Mr. Roth, you have 7.15 to the negative 8% chance of winning. It's a really small chance, but it's not zero. It's a good thing.
All right. Here, I'll give you something that is relatively similar to this. And when you think you're ready to do that, so you take out a coin and flip it. You're going to get heads or tails. Choose one of them. Say you want to get heads. Okay? How hard would it be to flip a coin and get heads 23 times in a row? Pretty hard. Pretty unlikely. Okay, that's still a better chance than winning this lottery.
Wow. What's the exact
Okay.
probability?
What is the exact probability?
What's the exact? How many?
23 is a 1 in 8 million chance. If you go to 24, that's a 1 in 16 million chance. So you're better off doing it that way. So your chances are very, very small. Four, 5, and 7 are a practice for this. But depends what your purpose is of the lottery. If we're going to talk about lottery for a little second here. If you are buying a lottery ticket because you're expecting to win, well, that's a really bad use of money.
Yeah.
However, when you do buy a lottery ticket, you are purchasing something that you can't purchase if you don't buy a lottery ticket. You're purchasing the entertainment to dream. Because I don't buy a lottery ticket, I can't really dream about winning the lottery and what I would do with all of that money, because I know I can't win if I don't buy that ticket. But if you do buy that ticket, you have, depending on when the draw is, might be 3 days, might be 4 days, of being able to dream. What if I won? And so what happened was, I saw a video. What they did in Britain, they had a similar game. They had Lotto 649, but they changed it to Lotto 659. And so now the chances of winning were less, but the price of the ticket was the same. So if you were trying to win, now your chances are worse. But if you're paying for the dream, they added something. They added the fact that if you guessed 2 numbers right, you won a free ticket to the next draw. That's it. But as far as paying for the dream, if what you're paying for is the dream, the guy was saying that the British one now is way better than it was before. Because not only are the prize number bigger, the prize amount is bigger because less people win, but you can, when you pay your $5, you still get the same dream, but now it's a bigger dream. So that's good. And you have a chance of winning a free ticket, which just lets you dream for longer until eventually you don't win and you have to pay $5 again to start that dream up again. But if that's why you play the lottery, and if that ability to fantasize is worth it for you, right, then it's $5 well spent.